Hey guys, Miss Wiggin here. Today I'm going to show you how to go from grams to moles. Forward, you should know how to calculate molecular weight. I am going to go ahead and calculate it here. So if you already know how to do it and just want to review, you can watch it. Otherwise, you can skip ahead to that point. If you don't know how to do molecular weight, you should be strong on this before you get to this type of problem. So here is an example of the kinds of problems you might see. You might see something that says this: how many moles are in 23.05 grams of glucose? And I'm giving you the formula, which is C6H12O6. All right. So what is this question asking? To shorten it, literally, we're going to be going from 23.05 grams. This is what we're given. And remember to always write your units, even if you're not totally sure what they mean. You do need to know that, especially when you move into multi-step problems. All right, C6H12O6. And we want to know how many moles is that? How many moles? All right, we're not trying to find the number of atoms or anything, just how many moles. All right, so this is what this problem means. The very first thing I have to do here is find molar mass. And to do that, I'm going to go ahead and calculate molar mass. So to do molar mass is the thing that grams and moles have in common. It's called a conversion factor, and it basically lets you go from one unit to another. So that is a really important concept. So how do you figure that out? Well, we need to know what that conversion factor is. So just like when you balance an equation, you gotta account for each type of atom and how many there are. So right here I have carbon, I've got hydrogen, and I got oxygen. All right, so I'm gonna look up there and go and ask myself, how many atoms in this formula of each do I see? It's pretty straightforward. So I've got 6 carbon, I have 12 hydrogen, and I've got 6 oxygen. All right, so when you talk about how many moles per gram, you have to figure out, well, I gotta account for how much of each type of element is in it. So I'm doing that right here. These are gonna be my multipliers. I'm gonna wind up multiplying these times the values that I have. All right, here's my little multiplier. All right, so let's go ahead, and the things that you're gonna need one of your periodic tables, all right? And you're definitely probably going to need a calculator. All right, for these problems, you'll be okay not using a scientific, but when we start going to molecules and atoms, you're gonna need one that can handle some heavy-duty exponents, so you will need a scientific calculator. If you haven't got one already, pick one up. All right, so here we go. I'm gonna go ahead and look at my periodic table. I've got carbon on my table is 12.01. All right. I've got hydrogen on my periodic table is 1.01. And I've got oxygen, which is 16.00. All right. I have to also keep in mind what my units are. It turns out that these numbers also, for each type of element, is how many of that element are in 1 mole. You can use it this way. So another way to say that would be grams per mole. All right, and I'm actually going to point out here that it's not just grams per mole, it's grams of whatever you're talking about. So grams of oxygen, grams of hydrogen, grams of carbon, okay? You should know that. Now, I'm going to go ahead and just do these multipliers. Remember, I got these values from the periodic table. So I'm going to go ahead and calculate these out. All right, calculate these out. Because we got to know how much are these going to count inside of that molecule for their weight. So let's go ahead and do that. All right, and I'm actually going to take the time, 01 times 12.01 times 6, okay, 72.06, all right, and this is just my math step, 12.01, oops, sorry, 1.01 times 12, 01, which is unsurprisingly 12.12. All right, and last we got to factor in that oxygen. There's 6 oxygen atoms, okay, times 16.00, and put my 96 here, and there are 2 zeros there. Okay, so make sure you include them. All right, so these are the totals per mole. All right, but we know that we have one big molecule, so we have to add all of these together, right? Because they're all a part of this molecule. So we're going to add them up. So 96 plus 12.12 plus 72.06 gives us 180.18. Okay, and remember, we got units here. We can't. Don't leave your numbers naked. All right, that's super embarrassing. Also, they'll do things when you're not looking that you don't want them to do. So it's a 180.8. Okay, so it's going to be grams per mole, but remember here, it's going to be grams of glucose. So I'm going to write grams C6H12O6, okay? All right, this is how I got there. Now this right here, whoops, got something very important, and this is over, right, 1 mole, okay? Very important. Okay, so I'm going to go ahead and erase this work here because the only thing that I needed, I did all of this wonderful stuff right here for this number down here. This is the important part of what we're doing here. All right. Okay, so this number right here is quite magical. It's magical because it is the thing that talks to other things. And when I say the thing that talks to other things, I mean it tells you grams and then it converts it for you to moles. The thing about conversion factors, which are so great, is you can flip these. You could say 180 grams per 1 mole, or you could also write this as 1 mole. 1 mole is 180.18 grams. Make sure you say what you're talking about. C6H12O6. Okay. So you can write this either way. It does not matter. All right. I'm going to leave it in this format. Okay. So let's get back to our original question. Our original question was, okay, well, how many, if you have 23.5 grams C6H12O6, how many moles is that? Cool. So what you're going to do is you're going to start with what you're given. You are given this number. So I am literally going to erase this because I need some room here. I'm going to set this problem up this way. This is called a railroad, well, I call it the railroad technique because it kind of resembles a railroad track. All right, I'm gonna do it like this. And all right, so what's going on here? Okay, so I want to get to moles right now. Up and down means to divide. Across means to multiply. And right now we're in the, and this is over a whole number. It's just over 1. Okay, So I'm going to take this and I'm going to go ahead and I know that I want to go to moles. So whatever I get after all of this should be in moles, we hope. Question mark. And I'm going to leave some space for my math. I always have a math step here. I just do a math step right there. It's going to be in moles. And so I'm going to go ahead and I'm going to take this conversion factor down here, 180.18, and I notice that I have grams and I have moles. Well, right now I'm in grams. I want to get rid of grams. So I'm actually going to take this conversion factor right here. I'm going to flip it because I want that grams to cancel out. And if you remember in algebra, something is on the bottom of, if you divide by itself, it's gone. And I kind of want it to be gone, okay? So I'm going to take this grams, which would normally be on the top, and I'm going to do just what I said right here. I'm going to say, instead of saying it that way, I want to say it this way. These are the purposes that I need for right now. And you might be in a situation where you have moles here. It's okay, you can flip it the other way, all right? So here I go. I'm going to go ahead and put grams down at the bottom. So I'm going to drag the number. The number goes with the grams. 180.18 grams. And notice I'm going to say what it is. Grams of C6H12O6. Okay, I'm going to stick that right there. No big deal. Now, I can't forget about the other part of this factor. I can't switch around things randomly. It's over 1 mole. Alright, so, alright. And I'm doing this version here. I just flipped it. Okay, so your math step, what I usually do, and in this situation, it's all by 1, so my math step is going to look kind of plain. I'm literally just going to multiply across, and I'll do that math step in a different color. 23.05 times 1 is just 23.05. All right, I'm going to be dividing by 180.18. Okay, this is just my math step. That's why it looks messy. If I had another number here, I would be multiplying. I did multiply. I multiplied by 1 here. All right, which I don't, you don't need a calculator to do that. So let's go ahead and let's find out what that is. 23.05 divided by 180.18. 180.18. Let's see what I get. All right, so I'm going to get a whole bunch of small numbers. It looks very small. Does that make sense? Well, yeah. The reason that your number is going to wind up looking small is it takes at least 180 grams just to equal 1 mole. So if I only have 23.05, it's going to wind up being a small number because I have less than a whole. So I know that whatever I get here is going to be a small number. After putting it in my calculator, I'm going to match how many decimal places here. For our purposes, that's okay. And I get point, and maybe I should do this in green, point 1, 2. We're only going to 2 places. That creates some problems for me, doesn't it? Point 1, 2. I'm going to go out. I'm going to match it to this. So I've got 4 here, 4 significant figures. We're going to do 4. Okay, so 1, 2, 7, 9. Oops, sorry, that's my. Went a little crazy with that 7. 1, 2, 7, 9 moles. And don't forget, I gotta say what I'm actually talking about. Chemistry teachers love to take off for this stuff. So moles of, you just drag it from what you were talking about, C6H12O6. All right, that is all you do for these. Anytime you're going from grams to moles, you start with what you're given, you take your conversion factor, all right, you set it up so it's correct. This is the hardest part here, and you can always know that you're trying to get it correct by setting up the grams so that they cancel. Thank you so much. Good luck. I'll see you in class.